And good morning, everybody. Here are your notes for IXL.com, Algebra 1, Module AA.5. And it's going to focus on factoring quadratics with other lead coefficients, so lead coefficients that are not 1. So if you remember the standard form for a quadratic, y equals ax squared plus bx plus c is what we call the standard form. And what we're going to be looking to do is put this into a factored form where we have a binomial times a binomial, and this is going to be the factored form. But it's going to be a little bit different than the other module we did. We're going to have an A value, so a lead coefficient, that is not just going to be a 1, so there's going to be some other number there. And we're actually going to use factor by grouping to do this. So yesterday we studied factor by grouping, module AA.7. So we're going to do factor by grouping and using what we learned in the other module AA.7 to factor these problems. And let's just go ahead and look at some examples from IXL.com. So here's our first example. So we have our quadratic. They want us to factor this. Notice it has a lead coefficient of 2. And it's going to be a little bit different than when we just had a lead coefficient of 1 there, in the sense that to find the correct numbers, you're going to need to do factors of the back number multiplied by the front number. So factors of the back times the front. So if we do the back number 9 multiplied by the lead coefficient 2, that's going to be 18. 9 times 2 is 18. And we're going to be looking for numbers that multiply to be 18, but they have to add up to be the middle number, which is 11. So they're going to need to add up to be 11. And it's probably easiest if you just list out your possibilities. So what are some numbers that multiply to be 18? So what are some numbers that multiply to be 18? We know 1 times 18 gets you 18 when you multiply, but notice when you add them, you don't get 11, you actually get 19. So this is not going to be a good combination. What are some other numbers that multiply to be 18? You could do 3 and 6, or 9 and 2. So 9 and 2, if you wanted to go in order, 3 and 6. And out of these combinations, which ones add up to be the 11 that we're looking for? So 9 plus 2 is 11. And 3 plus the 6 is a 9. So which ones multiply to be 18 but at the same time add up to be 11? That's going to be this combination right here. And what this is basically telling us is the middle term, 11g, came from a combination of a 2 and a 9 when it went through the multiplying process. When you're multiplying your factors back together, the 11 is coming from combining like terms of the 2 and the 9. So once we know what the right combination is, we're going to rewrite our expression. So it's going to be 2g squared, that was the first term. And where did this middle term come from? We're going to split it into the two terms that it came from before it was simplified. So it came from a 2g being combined with a 9g. So the 2g and the 9g is what created the 11g when it was being multiplied together from its factors. And then the last term is 9. So the second step in the process is once you know what the right combination is, then you want to go rewrite your quadratic and split that middle term. Now once we have 4 terms, now we can use the factor by grouping process that we were working on yesterday in AA.7. So if we look at the first group, what's common? A 2 and a g, so we can factor out a 2g. And what's left behind, we would need a g plus 1. Because 2g times g is 2g squared, 2g times the 1 is the 2g. And then what's common in the next group? looks like a 9, so we can factor out a 9. And we know what's left behind has to match the other parentheses, so let's just put it in there and then check our multiplication. So g plus 1, 9 times the g is the 9g, 9 times the 1 is the 9 on the end. So one of your factors is going to be the parentheses that repeat, so it's going to be g plus 1 multiplied by the two leftover factors, or the two leftover terms that were factored out, so 2g plus 9. So that should be your final factored form. Like any factors, you should always be in a habit of checking them by multiplying them back together. So you could go put this back in the answer box, see if you're right, but if you want to double check it before you do, that's probably a good idea. So if you were to multiply these two together, it's going to be 2g times the g is your 2g squared, and then 2g times the 1 is your 2g, and then 9 times the g is your 9g. And notice that was the 11 that we were looking for. The 2 and the 9, we're making the 11g in the middle. And then 9 times the 1 should get you 9. And then if we simplify it back to its standard form, we get 2g squared plus 11g plus 9, which is what the original standard form was. So that would check out. So again, this is just checking your answer. This right here is what we want for the answer. Those are our two factors that make that original standard form. And let's look at a few more without quite as much explanation behind it. Let's just go through the mechanics. So here's the next one. We're going to want factors of the back times the front. So we need something that multiplies to be 10. So they need to multiply to be 10, but add up to be the 11 in the middle. So what are your factors of 10? 1 times 10, 2 times 5. Which combination is going to add to be 11? Looks like the first one. So your front term is going to be 5z squared. Where did the middle 11z come from? It came from that combination of a 1 and a 10. So we're going to rewrite that in terms of where it came from. It came from a 1z and a 10z. And then plus 2 on the end. And once we have our middle term split, we can go ahead and do factor by grouping. So what's common between the first two terms? Just a z. And what's left behind? You're going to need a 5z plus 1. And what's common in the next group? Between the 10z and the 2, you're going to have a common factor of 2. And what's left behind should be 5z plus 1 if we're doing everything correctly. We'll check it in a second. So your 2 times the 5z definitely makes the 10z. The 2 distributed to the 1 definitely makes the 2, so that looks good. So one of your factors is going to be the z plus 2. And then the other factor is going to be the two matching binomials. So 5z plus 1. And those should be your two factors. And again, always check this by remultiplying. Even if you do it mentally, you can just multiply it back together mentally. So z times 5z is the 5z squared. 2 times 5z is the 10z. 1 times the z is 1z. So 10z and 1z is the 11z. And then 2 times the 1 is 2. And here's another one. So we want to find factors of the back times the front. So we need factors of 21 that sum up to be 10, the middle number. So what multiplies to be 21 but adds up to be 10 in the middle? So factors of 21, that's going to be 1 and 21, or 3 and 7. So which combination adds up to be 10? That's going to be this one. So your 10n is coming from a 3n and a 7n, so we're going to say it's 3n squared plus 3n plus 7n is making the 10n in the middle, plus 7 on the end. Don't worry about what order you put those middle terms in the expression. Either order is going to eventually work. So you don't have to worry about whether it's 3n plus 7n or 7n plus 3n. Either one's going to work. And let's do factor by grouping. So what's common on the first two terms? A 3n, and what would be left behind? Looks like a n plus 1. And what's common in the second group? Looks like a 7. So we can factor a 7 off. What's left behind? It needs to be an n plus 1 to work. Just check it real quick. 7 times n is your 7n, and 7 times the 1 is the 7. So one of your factors will be 3n and the 7. And then the other factor will be that common factor, n plus 1. So that's going to be your factorization for that one. So 3n plus 7 multiplied by n plus 1. And here's another one. This one's a little bit different. It has a negative on the last term, a -5, but the process is the same. You're just going to have to deal with positive and negative numbers. So we're still going to do factors of the back times the front. So we're going to look for something that multiplies to be the back times the front. So the back number is -5, the front number is +5. So -5 times +5 is -25. So we're going to be looking for things that multiply to be -25, but they need to add up to be 24 in the middle. So first let's just find some numbers that multiply to be 25, and then we can put the plus and minus signs on them to make it negative where we need to. So what are combinations that make 25? 1 times 25, and then 5. So 5 times 5 is 25. Both of these, the way they're written right now, they're both positive. So if you multiplied them, you would get positive 25. To get a negative 25, one of the numbers will have to be negative. So for example, in the first combination, if you had a -1 times positive 25, you're going to get negative 25. Or if you had a negative 25 times a positive 1, you're going to get negative 25. So the question is, where do you want the negative? If you notice what we're trying to add up to, we're trying to add up to a positive value, so positive 24. So you're going to want more positive value than you are negative value when you're adding them, combining them. So we're going to give the negative to the smaller number, the -1. So -1 times 25 is -25, but when you add them, you have -1 plus 25, so that's going to get you positive 24. So this is going to be the correct combination to make a -25 when you multiply, but a positive 24 when you add them. And then from there you can go ahead and rewrite your quadratic. So it's going to be 5x squared. Where is that middle term, the 24, coming from? It's coming from a -1x and a positive 25x, and then a -5 on the end. So what's common on the first group? Looks like you can factor out a x and 5x minus 1. will be left behind. And then check it. X times 5x is 5x squared. X times a negative 1 is negative 1x. And if we look at the second group, it looks like there's a 5 in common, so you could factor out a 5. And what's left behind? A 5x minus 1. And then check it. 5 times 5x is the 25x. 5 times the negative 1 is negative 5. So one of the factors is going to be x plus 5. And the other factor is going to be the repeated binomial, the common factor, 5x minus 1. So there are your two factors, and then you can check it by remultiplying. And here's one more example. This one has a little bit something new in it. Notice if you scan through all your factors first, all your terms, there's a common factor for all those terms of 5, so you can factor a 5 off first. So if I pull a 5 off of each one of these terms, then you're going to be left with a j squared plus 3j minus 10. Check it through redistribution, so distribute the 5 back in, you get your 5j squared back, you get your 15j back, and your negative 50 back. And now we're left with a quadratic. Notice on this one you actually don't have a lead coefficient. Your lead coefficient is actually a 1 right here. So now you can just use the factoring technique that we were using a few days ago. So in one of the earlier modules, when we had a lead coefficient of 1, what we were saying is to factor this, we just need to find factors of the back, the negative 10, that sum up to be the middle, which is 3, which is kind of the same thing that we've been doing for this section. If you think about the back times the front, well, the front number is just a 1. So negative 10 times 1 is just the back number, negative 10. So when the front number is always 1, then you're still kind of doing factors of the back times the front that sum up to be the middle. You're just really focused on the back number because the front number, that lead coefficient on the j squared, is just a 1. So what are some numbers that multiply out to be 10? So we can do 1 and 10, and 2 and 5. We want positive 3 when we add. So the 2 and the 5 is going to make a 3 somehow. If we give a negative to the smaller number, then you will get positive 3 when you add them. So one of the factors was 5, and then if we think about the other two factors, to make the j squared, you obviously need j times j. And then to make the 10, you need a 2 and a 5. And we need it to be positive 3 in the middle, so we're going to give it a positive on the 5 and a negative on the 2 to get that positive 3. And those are going to be your two factors for that quadratic, plus you had that original factor of 5 at the beginning. So for this one you actually have 3 factors. One of them is just a numeric factor, and then you have your 2 algebraic factors. And if you multiply that back together, you should produce the original standard form. And what you're going to need to put in your answer box is this right here. And that would be your factored form for that original quadratic. And that is it for this section. That's your notes and your examples for IXL.com, AA.5, factoring quadratics when you have a lead coefficient that is not 1.